morning and welcome everyone on this international webinar on innovative research trends in green electronics and allied technology by Department of Electronics, Tuljaram Chaturchand College, Baramati. I, Dr. Aparna Pawar, welcomes you all on this second day of webinar. On today, I invite Dr. Shashikant Saristap, Chief Scientist, CSIR, Siri, Pilani, Rajasthan. He speak on water quality aspects and treatment method to get usable water. And to introduce him, I would like to call upon Mr. Aniket Kothawade.
Good morning, everyone. Myself, Anekant Assistant Professor in Electronics Department. It's my pleasure and privilege to introduce the resource person of the webinar, Dr. Shashikant Sajista. Let me introduce Dr. Shashikant sir before his address. Dr. Shashikant sir is a chief scientist in Siri Pilani, Rajasthan. He has more than 31-year experience in development of real intelligent embedded system design and application of water, agro, and power sector. He has worked as a visiting scientist in Department of Biosystem Engineering, Winnipeg, Canada, on development of sensor technology for agriculture and grain storage applications. He has ample of publication in his credit at the national and international level. His international publications are 30 and national publications are 25. Dr. Shashikant got prestigious Scotch Award, India's Best 2015 in Smart Technology for Aero Automation for Rural India from Smart Technology Award on 11 December 2015 at New Delhi. Dr. Shashikant got patent on equipment for time sharing of single AC motor soft starter with more number of AC motor in 1998. So it's our honor and great pleasure. I warmly welcome you, sir, on behalf of the Department of Electronic Science. Now may I request today's speaker, Dr. Shashikant, sir, to deliver his speech. Thank you.
Good afternoon, everybody. Today's topic is water quality and treatment process. Now, everybody knows that fresh water availability in world is very less. About 97.5% of the water on earth is in ocean and only 2.5% fresh water is available. So out of that, 70% is permanently frozen in glaciers, 30% water is groundwater, and 0.3% water is in rivers or lakes. So if you see that the current freshwater demand by 2025, then you see that there is a red area. You can see that red area where there is a high water scarcity, okay, including India. Okay, so now water is going to be a big problem by 2025 unless otherwise we take care of necessary, because rainfall is already less. And second thing is that we all depend upon mainly rain, okay, in India particularly. So whatever water available, the resources available, we need to protect it and conserve it and also treat it very well. Also, there is a challenge now how the wastewater or used water can be retreated and reused. So water reuse and water treatment are main focus of today's contest. So typical water use, if you see that most of the water, since India is a agriculture country, so most of the water requires for irrigation, right? About 85%. Then if you see the domestic percent, that is only 7%. Then next is industry, around 2%. Energy, very less, and other like washing, etc. So it is around 7%. So total, if you see that out of 100%, most of the water need is in agriculture or in India particularly. So why you require water quality monitoring? It is because you know that for rational planning of pollution control strategy and their prioritization. So already you have water resources like river, ponds, or the underground water, etc. So now, what is the pollution in that particular water resources? Then how we can control the pollution? For that purpose, you require actually what amount of pollution, what kind of pollution is there. So you should know actually nature of the pollution and how much it is polluted, bodies are polluted. So to evaluate it, so you require pollution control measures to evaluate water quality trends over a long period. So particularly you might have seen that during the rainy season, water gets highly polluted because of other water flows goes and mix with the water resources. So particularly rainy season and particularly other seasons also, because of wastewater mixing with the resources, etc. That is a usual problem in all over the world. Now, to assess the capacity of water body, then how to control this pollution by cost effective manner. Then third is to understand the environmental fate of different pollutants and what are the kind of treatment required to get it in a usable form. So that is the main objective of our water quality monitoring. Now, if you see that for water, there are physical parameters as well as chemical parameters for assessment. So, physical parameters like water color, odor, turbidity, temperature, conductivity, etc. And while uh, in chemical parameters, you know that pH, acidity, alkalinity, hardness, solids, and some harmful chemicals, which like chlorides, sulfate, iron, nitrate, heavy metals, and pesticides. So some of the problems we can easily see by our naked eye or by smelling. So basically, common problems what we can observe by visible effect, water turns black or smell is there, bad smell. So maybe reason the wastewater is uh, get included in that resource. Okay. Next is acidic test, basically because of low pH. Alkaline test because of high pH, means pH is above 9 or so. Then boil rice hard or yellow, that means high alkalinity, means alkaline contents are more, TDS is more. Then hardness. So that the TDS is the main measure, the TDS or conductivity. So if your TDS is more than 3000, so water is called brine, and that's why it is hardness. So you will find white deposit on the boiling. When you boil the water, you see that white deposit on the bucket or on the pot. Then iron test or change in color after exposure to atmosphere, change in color of clothes, etc. because of iron content, mainly iron content. Okay. Then soap or lathering, there is because of hardness. Okay, water hardness is very high. And brownish black streak on teeth, that is because of fluoride effect. So particularly in India, if you see Rajasthan part and some other north part, so where fluoride is more. Okay, so more than usually the limit of fluoride you should be less than 1%, but usually here you will find even it is more than 1.5% to 2%, or even in some cases more than 2%. So fluoride is a mainly problem. Like arsenic also in Bengal or this side, you will find that arsenic also is a main problem in water. Okay. Then growth of algae. So growth of algae means what? Nitrate and phosphate contents are increased above their limit. Okay. Then fish killing. You might have seen in particular rivers, ponds, or sometimes ocean. You find a lot of fish get killed because of what? Low pH and less dissolved oxygen. As no, that's like a human being, fish also require oxygen. So that's just like human being get oxygen from air. Similarly, the oxygen get mixed with the water, what we call dissolved oxygen. So dissolved oxygen, this is required to fish. So if dissolved oxygen get less than 4, so then it is a critical limit for the fish and fish may kills. And there is a natural tendency that even few percent fish kill in a pond or that source, then automatically within 24 hours, almost all fish get killed. Okay, this is this is usually happens in Bengal, Assam, where there is particularly in Maharashtra, where the sea ponds are there. Okay, fisheries, particularly fisheries business. Then water having salty taste means chloride is more. Okay, so if you see that there are so many parameters, now how to measure? Because these parameters, whether these are physical or chemical, there is certain kind of methods to measure. There are certain kinds of instrument to measure. So like pH, electrometric method is used. Turbidity is measured in NTU. Turbidity meter is used. True color, it may be visual comparison method or maybe nowadays image processing. Okay, by camera also you have a mobile app which can detect the color change and you can indicate that the water is pure or not. Then electrical conductivity or maybe turbidity. I'm sorry, conductivity is reciprocal of TDS. Okay, so Electrical conductivity method is the main measurement of electric conductivity, or TDS. Okay. Then iron, ferroware method, manganese, pan method, sulfate, sulfur for diametric methods, fluoride, Spans method, alkalinity titration method, total hardness, EDTA, uh, titrimetric method, and then chloride, argotometric method. So nowadays, even these are the all chemical. Mostly these methods are chemical methods. But nowadays, now sensors are available. Direct sensors are available. Electrochemical sensors, or even non-contact optical sensors are available to measure TDS, TO, pH, uh, so and so forth. So even fluoride is also measured by non-contact techniques. Arsenic also measured by non-contact techniques. So nowadays, this kind of sensors and instruments are easily available. Now, if you see in a national water quality monitoring kind of documents, then apart from these physical parameters and chemical parameters, there are other parameters. So these are maybe COD, BOD, ammonia, then suspended solids, fluoride like boron, then P alkalinity, phosphate, sodium, etc., etc. And apart from that, the field observations where you are actually taking the measurement, water quality, where you are taking the samples. So weather condition, then depth of the stream where you are taking the samples, color intensity, and so on and so forth, station details, then biomet monitoring parameters, right? Then trace metals where the industry waste is there. So particularly in industry outlet, this arsenic, nickel, copper, mercury, all these tests are done. Usually basically where the heavy metal trace is get mixed with the water bodies. And then pesticides, because when you know that in agriculture mostly people use pesticides, and the wastewater from agriculture, so they may have the pesticides more than their limit. This water get mixed with the water bodies like rivers, ponds, etc., and that also harm the water quality. So that is the criteria for selection of monitoring stations. So particularly if you see the river stream, then water intake point, water outlet point, maybe in between points. So depending upon whether you are in a village or in a semi-urban or urban city, or maybe a large city, mega city. So there, depending upon that, whether it is industrial area, so number of points can be increased from say input source to say outlet. So you can have a 3 4 points where you can say that you can take the water samples or do measurement directly, right? Then source of river, the quality where the quality is highly degraded, also or irrigated area where the agriculture area is more. So in that region also you can take water quality measurement, and so on and so forth. So state boundaries, particularly interstate boundaries, interstate villages boundaries also you can say. So these are the some of the criteria where you can say the monitoring stations are installed already. In big rivers, government of India installed monitoring stations like Ganga, Yamuna, Godavari, etc., and they are regularly taking the samples 24 hours. Okay. Then the other source of water is lake or reservoir, ponds or tank. Here also, point of extraction point where the water is coming. Then whether there is a bathing, like mostly people use animal bathing, etc., water in lake, etc. So that point is crucial for measurement, and other points also. Vicinity, if suppose in vicinity of lake there is some wastewater tank or something like that, so there also the point becomes crucial for measurement. Apart from that, as you know that in Rajasthan and many part of area, there is no lake, there is no river, ponds, etc. So there, main water is groundwater. So groundwater resource also, as you go deeper and deeper, naturally the TDS of the water get increased, and while having the wells, ground wells, if there is a seepage from the sewage point of view, then also septic tanks, garbage dump, etc., then automatically this groundwater also get affected. Water quality also degraded due to because of this seepage from this kind of applications. Then tube wells, hand pumps, and dug wells in industrial area. So particularly in industrial area, so industrial wastewater get dumped in the that area, so it may get absorb in nearby grounds. So that may make a channel to mix with the tube wells or hand pumps. That this is also have seen in many places, particularly in villages where hand pumps are installed near the industrial areas. So, what is the water quality criteria? You see that, particularly according to our Indian standards and international standards. So, drinking water source without conventional treatment. So, without treatment, what is the water quality? So, which is called Class A. So, total coliform organisms should be less than 50. pH should be between 6.5 to 8.5. Dissolved oxygen should be minimum 6 milligram per liter or more, and then biochemical, so this BOD, etc. So they are limit for A class A. Then outdoor bathing, suppose this is swimming tanks, etc. For that, there are certain criteria is there. Similarly, drinking water after treatment, so particularly after treatment, what should be the quality? Then here also you see that total coliform organisms should be less than 5,000. pH should be 6 to 9. Dissolved oxygen minimum should be 4 mg. Okay, and more. Okay, and then BOD, biochemical oxygen demand should be minimum 3 milligram or less. Then proper wildlife fisheries, particularly fisheries where the people are doing fisheries business, so their pH is very critical. So you should maintain for healthy fish and wildlife. You should maintain the pH between 6.5 to 8.5. Dissolved oxygen should never go below 4 milligrams. So it should be more than 4 milligram per liter. Okay, and then free ammonia. This is also because usually this wildlife fisheries waste get mixed with the water. So ammonia content also NH3 component increases. So that may also harm to the fish. So that's why that also critical limit ammonia. In particular aquaculture like DO, pH, ammonia is also one of the major critical parameter. Particularly irrigation where the agriculture land, industrial cooling, control waste deposits. Here also pH should be 6 to 8.5. Conductivity, TDS or conductivity should be the TDS should be less than 2000 ppm. Okay, then sodium absorption ratio should be, sodium content should be less than 26. Similarly, boron should be less than 2 milligram per liter. So these are the typical criteria already accepted and implemented in India and abroad also. So if you see water pollution, what are the major, water pollutant? Who makes water pollution? Who affect the water quality particularly? So mostly agents are bacteria, viruses, protozoa, parasitic worms. Source where from it comes, human or animal waste. Then oxygen demand waste, basically because of organic debris and plus and waste or aerobic bacteria. Main source sewage, feedlots, paper mills, food processing units, etc. Inorganic chemicals, acids, metals, salts, mainly sources surface runoff. Okay, so during rainy seasons when there is a storm, water will run. So at that time, this acid, metal, salt, whatever is available uh, on the floor, it get with mixed with the water runway, and it will get mixed with the that in the either in the industrial fluid, or maybe that rainwater will get mixed with the water resource like river, ponds, etc. So the inorganic chemicals. Similarly, radioactive materials. These are so iodine, radon, uranium, cesium, thorium, etc. We mainly source is coal and nuclear power plants. So wherever these coal and nuclear power plants are there, so they in that outlet, and or particularly mining sector, particularly like Rajasthan, there is a mining sector, Bihar there is a mining sector where weapon production unit. So here also this outlet water get mixed with the source of water, which may contain this kind of radioactive materials, right? Then plant nutrients, basically sources, sewage, manure, agriculture runoff, landscaping runoff, etc. Organic chemicals like oil, gasoline, plastic, pesticides, detergents, sources, industrial effluent, household cleaners, runoff from the farms and yards. So these are the major sources of pollutant, and the depending upon how they get mixed with the water bodies or water resources, so that affect the water quality. Now if you see the picture, really this is a typical picture of particularly groundwater pollution. So if you see that there is a groundwater, then you have a different, industrial waste, farming waste. Okay, so this is all what we discuss is shown by pictorially. Okay, so here also you find that not only the surface water but also groundwater may get affected because of this waste from different regions. Similarly, the seawater also in coastal area also, if you see the coastal area part, then there is the industrial waste from the cities waste like toxic metals, oils from street, etc., sewage, then urban sprawls. So construction sites, particularly construction sites, and farmers, that is farming runoff from the runoff of pesticides, manures, fertilizers, etc. So all this get mixed with the rivers, and then finally that river get into ocean. So you have seen that many times the coastal region, near the coastal area, you find high content of pollution, the water pollution. Water bodies get polluted, highly polluted. So because of that, it affects the marine life. Fish get uh, died because of all wastewater in the. Uh, these are the effect, as I told you, because of pH and DO is not sufficient. So automatically this marine line is affected, quite affected. So you will get fresh water only at the middle of sea. Okay, if you see that, but where the another problem is the TDS is more. TDS of typically seawater is highly brine, so it is maybe 25,000 or more, like ppm. So that's why seawater is not directly usable for drink, and so you require some kind of treatment, right? Now, even though there are water laws by government, different government and agency to reduce the point source pollution, Clean Water Act, Water Quality Act, etc., etc., are there. Then there are also norms for purification of urban drinking water. Similarly, there are norms and regulations for purification of drinking water in developing countries. So all these exist documents. Up till now, people are not concerned about this. But nowadays, for last 10 to 15 years, drinking water become major problem. So you know that even people are saying the time will come when you have to spend more money for water than the gold. So that time may come. So before that, we should, take proper care of these natural resources. And water is a prime importance to everybody, each and every human being. So if you see the drinking water quality, what is that? Purification of urban drinking water, purification of drinking water in developing countries, and bottled water. Nowadays, water available is what we can say is everywhere you see that this bottled water is selling. Most of the people are now taking this bottled water. So there are norms and how they are to be processed. So everything should be followed up so that the water quality will not be affected and the human health will be of most concern. So now if you see the water treatment, now why aim of the treatment, basically why you require aim treatment, as already we have discussed, because there is a pollution, okay, in the water bodies. And how to remove pollutant depend upon pollutant, nature of the pollutant, you have to apply different kind of treatment. Then second is removal of solids from in suspension, disinfection, water treatment in emergencies, etc. So these are the more basic four aspects of water treatment. Now, if you see aim of the treatment of the process, so basically aim is the water, drinking water should be pathogen free, chemically safe, without dirt, solid matter, and it should be acceptable for the every human being, according to the WHO guidelines and national regulations for water. So next is the treatment process start in the water extraction sector. So it may be a groundwater, river water, or lake. So water is taken from a source collection. So it may be pump or whatever may be means surface water or groundwater is extracted. Then means of water extraction, strainers. So here also nowadays guidelines have been made. Initially people were not care about this, how to extract water, groundwater, etc. But nowadays also standard procedures and standard documents, rule regulations are made for extraction of the surface and groundwater. Similarly, water extraction from the deep wells and etc. Similarly, the treatment process ends in a distribution. So basically, when there is first of all, we'll go in that details. So what do we require? Water extraction, then you have storage, and then distribution. So it may be a jerry cans or maybe large tank or whatever, maybe a very high capacity tank. So all this is being used for storage. And then you have a distribution line. So pipelines will be there, where pipelines metal we use or plastic is used. So that depends upon the quality, whether it is a potable water or water for other use. Depending upon that, the distribution network is decided. Apart from that, in the distribution network, you might have seen that there is cracks in the line, supply line. Okay, so there is a leakage of water, there is a losses of water. So every time you have seen this kind of problems everywhere. Okay, now removal of solids in suspension. So the main is why it is required. So basically to improve the efficiency of disinfection. So what are the control parameter? Gravity analysis, like turbidity. So turbidity should be less than 5 NTU if you want to make a disinfection, and very useful, particularly after the pre-processing of the water. So what are different methods of removing the solids in suspension? Basically sedimentation, flocculation, and filtration. There are three methods. Okay, so first, if you see the suspension for sedimentation, advantage, it is very simple. No consumption of power, etc. required. No chemicals, but it requires large area, large facility, and it is very slow, and it is very limited quantity of water. Some gallons, 1,000 gallons or 500 gallons per liter of water. Such kind of tanks has been made. Now, second is flocculation. Here, what is that? A chemical treatment. It is basically chemical treatment. Factors are controlling temperature, time, and dose, chemical dose. This should be properly controlled to get remove colloids and with time and with proper equipments. So this flocculation process is effective than the first one, but disadvantage that it requires some chemicals and also control like temperature, time, and dose control. So naturally, this cost will be more than the first method. Okay. The third is nowadays filtration, because now this requires no chemicals, no any kind of addition, etc. So this is advantage. No chemicals, models possible for sterilization, etc. But what is disadvantage? Materials, because the material requires some cost. So just like a filter, so filter have different kind of filters are available. We'll go in details, and for that, backwashing is required. Just like in your home when you prepare tea, so you use a filter, okay, to remove the tea abstract. But now after that you backwash, right? You wash that particular cloth or maybe filter. So that's why particularly this filtration process requires a backwash to clean it. So this is the added expenditures in particularly filtration kind of thing. Okay. So then last stage is disinfection. So how you get it done? So basically to destroy germs present in the raw water, to destroy germs introduced in the treatment and distribution system like pipeline and storage, etc. So what is the basic uh, basically properties of disinfection agent? So basically heat treatment. Sometimes you put water is less, so heat treatment is used, UV radiation or chlorine. So chemical agent like chlorine, ozone, iodine, salt of ammonia is also chemical method. So basically chemical method, heat treatment method, UV radiation method, these are the popular methods nowadays used for disinfection of the water. So chlorination is common. So what is that? The percentage of STH, 70% of the active chlorine is used in, particularly if you go in, if you see a large processing water plant from in particularly urban area, so there chlorination is common. Okay, chlorination treatment is common. Second thing is even your swimming tanks also, you might have seen that chlorination is also common. But what is the disadvantage? If the chlorine gets more than what is required, then there is a itching of eye and there is other effect to the human body. Okay, so that's why you have to process the chlorination treatment properly. Okay, so that is also one of the limitation of chlorination. So as I said, dose the proper doses. So chlorine liquid test, then contact time with water, then pH and temperature should be maintained. Okay. So final range will be typical range of chlorine addition is zero point 0.4 to zero point 0.8 milligram per liter. And sometimes shock chlorine treatment also given for disinfection by chlorine. So if you see that any source of water is there, you have raw water extraction, so from the source, then you have input tank, then pre-oxidation, then as I say that flocculation or any kind of method you can use, clovulation or flocculation, then sedimentation. So you have a waste like sludge is removed. Then after that sedimentation, you can use silex filters to remove wastewater. Any kind of wastewater is there, it can be removed. Then after that, it has been taken to carbon filter to remove the smell, bad smell, etc. Carbon filter used. And then finally you can, after that, you may do chlorination treatment or UV treatment, whatever may be available, and you have a output drinking safe water. So this is a typical water from body, anything from water, you extract, you store, then treatment, then you have a final treatment. So to get the pure safe drinking water. Okay, so this is applicable as to those water bodies where TDS is less than 800 ppm. If TDS is more than 800, then naturally you require some kind of treatment, just like a RO or other ultrafiltration, etc. Because TDS is high. So you might have seen that people use RO systems in our house, particularly when TDS is more than 1000 ppm. Okay, so that water is not safe for drinking. So naturally you require some ultrafiltration or RO. So to get the proper ppm below, in Indian context it is 600 ppm. According to WHO it may be 100. Sometimes people may misuse the RO because RO process. As you see that in cities or in many areas where there is a river water, so TDS is not much. Okay, rain water is there, so TDS is less than even 300. So for that you do not require RO. Okay, so for that you can use pre-treatment, as I said, this pre-treatment, and then you can have here after that carbon filter. You may have micron filter, 1 micron, 5 micron filter, and then maybe ultrafiltration. Ultrafiltration technique you use, and ultrafiltration, and then you may have UV, so that TDS will not change. Okay. Well, otherwise, what will happen? If the input TDS is less than 500, then naturally to our RO will be TDS will be output of RO TDS will be less than 100. So this is also harmful. Just like human requires some kind of salt, water also. So that's why minimum TDS should be less than more than 100, or minimum should be 150 ppm. Okay. So this is because many people I have seen that even the TDS is less than 500, they put RO systems and then they say our TDS, high pure water they are taking. But in that, when TDS is 60 or 40, so they do not get the proper salt which is required for body, and that also be harmful. So that's why TDS should be minimum should be 100 or more. Safe is 150 to 300. Okay, for any human beings. So it's a potable water. Okay. So if you see the picture here, same. Now I have shown you line diagram. This is a picture. So you have pumping water from the source, then you have storage tank, then water treatment. Okay, then you can, after pre-treatment, you can have a submersible pump again. Then you have flocculation tank. Then from flocculation tank you can have a pressure gauge. So you have a silex filter, then carbon filter. Then this is a chlorine treatment. Okay. Then whatever the chlorines are added here. Okay, as a proportion I told you, according to what is suggested or recommended by water experts. Okay, so this is a chlorine treatment. After chlorine treatment, you have a carbon filter. So any kind of smell still remains in the water is removed in the carbon filter. So and then you have chlorine treatment, and then this water may be stored in bags or in a container, so that it can be taken for water distribution. Okay, but now here also mainly you have find that here also when the water is kept here, these tanks are usually iron tanks. So naturally rusting of the iron takes place, and this rusting get mixed with the water. So even in the distribution side, if you do not put filter, okay, there after this tank, then also this minute particle of this iron or this rust get mixed with the drinking water, which is common in the particularly area where the tankers are supplying the water. So what you have to do, you have to put filter. This water you cannot take directly and use it at the home. So you use filters are available in market around 200 rupees or 300. It is cost effective, so use that filters, and then if you require, you may use alum or you may use chlorine, slightly chlorine tab, so that any disinfection or any bacteria is there, it will be killed, and then you can use. So initially in old days you used to treat, boil the water, but boiling was the common, but nowadays it is a very slow process and it takes a lot of time. So that's why filtration and UV treatment or this chlorine tap treatments or ram treatment is becoming common. So now if you see the water treatment, now conventional sewage treatment, where the same thing, just like drinking water, some wastewater also treatment, as I told you initially, that wastewater should be treated and reused. So the water reuse also becomes important nowadays because we have scarcity of water. Okay. So that's why wastewater from different region is treated by different processes. So here also you have common process: collection, combined sewage, carry storm water and wastewater, separated sewers, sanitary sewers, storm sewers. So they are all kind of sources. Okay. Now these are water from this all sources or resources. As for example, septic tank in a particularly village kind of rural area, suburban area, rural area, septic tank is there. Here also, the septic tank must be properly installed in soil sand with the adequate drainage, not to be placed close to the near site, like drinking well or drinking pump, hand pumps, etc. So that this also requires some kind of precautions. Septic tank, as you know, so this is a common method in villages and suburban urban area where septic tank methods is successfully used, and when the tank is full, that has been taken out and then it is disposed of at suitable site. Okay, so when the settling tank becomes full, it is removed and disposed of. Similarly, some chemicals are added so that the smell should not be there, and it should not harm also the human beings who are staying nearby that. Even some people have used this to prepare the biogas. Okay, this is also another technique. The septic tank also been collected, and then that biogas is created, and that biogas is used also for cooking, etc. in some part of rural India. Okay. Similarly, here also the same thing pictorial. If you see that in a city, so you have sanitary waste, so waste from this is rainwater, rainwater flow, storm sewer. So that is not filtered. So rainwater is simply get mixed with the river. Okay, basic. And other water is treated. Here is a every now it is essential whether it's a suburban, urban cities. Now there are septic sewage treatment plant are must. This is according to the new rules of water treatment body, water department of India. So you will find that sewage treatment plant located at around nearly 8 to 10 kilometers away, and everywhere this after treatment only the water is mixed with the river bodies. Okay, so this is what must. So urban cities or semi-urban cities, this sewage treatment plant is essential nowadays. Similarly, where the industrial area is also there nowadays, you have to use a industrial area has to put properly wastewater treatment plant, and then only water should be allowed to mix with the river. So this is also becomes a essential condition for the uh, urban or semi-urban area. So if you see that pictorially, just like what I have seen that drinking, similarly here also wastewater, your water intake, okay, there is a screen bar, so filtration, grill chamber, then there is a settling time. In that settling time, the sludge will be removed off, so then it will be dried and it will be disposed of at proper places. And then it is from the settling time, water is there. it is taken pumped up in aeration tank, so oxygen get mixed, activated slug, air pumps will be there, so oxygen get mixed with that. Then this water will be taken into settling tank again. From here also, some whatever amount of still, if slug is left, it is also removed, so you get pure water. Then in that pure water you may use chlorination techniques, and then it should be sent to the river or lake. Okay, so the chlorination is measured mainly here. UV is not used. Chlorine is the main treatment agent. So to kill the bacteria, and then it will be mixed with the river water or ocean. Okay, so this is a typical wastewater treatment process. Okay. So another area, as I told you, that drinking purpose. Now desalination, water desalination is also become a important method of water treatment. So why desalination? Again, why? So 75% of Earth's water, surface water, is covered by water, and mainly it is the ocean. So TDS is more than 10,000, or in some cases more than 25,000. So only 1% available water for drinking. Now most of the Gulf country, and you see, and in all Middle East, you will find that the RO desalination is the main unit where seawater is treated and is used for drinking and all this. Okay. So this is become a main. So seawater also become a main source of after treatment drinking water, to particularly areas nearby seashore. Okay. So if you know that water cycle, it is a common. And this is natural water cycle where water from whether is the sea, it is evaporated, then condensation, then it becomes cloud, then again then it will be in the form they come down, condensation, precipitation, and then this maybe in the form of ice or rain, it will come down, then through small rivers or small channels, it will get with the big rivers, and finally it will go in. Some water will be discharged in ground, and most of the water will be flown to the sea again. So this is a typical water cycle. Okay, so this is a common, which is naturally happening, but it is not sufficient because the water demand is more. So what are the different methods? So there are two major types of processes. One is membrane process. Okay, when in that membrane process, reverse osmosis RO, then forward osmosis, and electrodialysis EDR. These are the three methods which is successfully applied everywhere, including India and all over the world. It is already successfully used. Okay, what is other? Thermal D. In thermal also multi-effective desalination, MED, multi-stage flash, membrane distillation, and vapor compression. So thermal desalination also method is being used in Gulf countries. In India also Kutch area, where the sun is more, sunlight is more, and thermal methods are in some cases are cost effective, but in some cases it requires large infrastructure cost. Okay. So this is a typical, desalination by thermal process. You are heating it, so condensation, then the other waste will be removed, and you will get a pure water. Okay, so this is a typical diagram showing how the thermal desalination is taking place. Water is heated, evaporated, and collected. So it is a clean water, and the brine left is removed. Okay. Example: multi-stage flash desalination. Salt water enters the system and is boiled and then evaporated in each chamber. Okay, process produces clean water and brine. So brine is removed and you get a safe water. Okay, so this doesn't require, a small plant does not require much cost. Okay, only heating. So now heating may be done by solar, by wind energy, or even at the seashore by tidal energy, or maybe mix of that. Okay, maybe hybrid. Okay, so depending upon the what kind of heat treatment is there, so thermal desalination is carried in many cases. The second one, as I told you, membrane desalination process where salt water is forced. Okay, there is a pressure forced through membrane sheet at high pressures, so that membrane sheets are designed to catch the salt ion. So particularly most of the heavy ions will be removed and only essentials will be taken off. So this is a typical RO, but what is the problem? It is ideally the RO process, this membrane process, desalination process, Our process have efficiency of up to maximum 65 to 70%. So waste is more. Okay, right? This is the only disadvantage of the RO process. So particularly if you see example, salt water is forced through a membrane at 600 to 1000 psi. Okay, so you may have depending upon TDS. So TDS you cannot convert 30,000 ppm salt into less than 500 in one stage. Okay, so such kind of membrane are not available. So that's why you require a multi-stage. So 30,000 is brought to suppose to 2,000 and then 2,000 to 500. So minimum 2 stage or 3 stage plants. Usually it is called multi-stage plant. Okay, RO plants are installed to convert seawater into a potable water, and the reject is again sent back to the sea. Okay, the waste will be sent to a sea back. Reject of the RO is also sent back to the ocean again. Okay, so as I told you, this filtration depending upon the porous size. Okay, so different methods are there. Just like zero point 0.1 micron, this is called microfiltration. What it removes? Particles, sediments, algae, bacteria is removed. Okay. Second is ultrafiltration, 0.01 micron process. Okay, this is my size. So most of the small colloidal viruses is removed. Okay. Then nanofiltration, which requires 1 nanometer. Okay, porous. So dissolve organic matters like calcium, magnesium, heavy ions will be removed. And then above that 1 nanometer and below, so we have reverse osmosis, where monovalent ions also will be removed like Na plus, chlorine, etc. And you get as fresh water. Okay, so this is a typical diagram. But for normal process like microfiltration, up to microfiltration, the pressure requires less than 1 bar. Okay, not much pressure is required. For ultrafiltration or some RO, you require 1 to 10 bar. Okay, for nanofiltration, pressure from 5 to 10 bar is required pressure. Okay, and for above, particularly for RO, you require 10 to 150 bar pressure depending upon what TDS level is at input side. So a picture really in thermal desalination, as I saw, that salt water is there. You have evaporation, so vapor is taken out, condense, water is there. Then that from water also you can use membrane to filter it, and you have a safe drinking water. Similarly, here also there is a brine is there, so brines may also contain some water, so it is heated at more temperature. So that again vapor will be collected, then condensed, and again it is through membrane, again collected to the clean water. Okay, and from that membrane, whatever reject, still it is there. It is converted into waste tank. Okay, so that has been not utilized for any purpose. Okay, so example, this plant uses two evaporation and condensation along with a membrane filter to clean the salt water. Okay, so this clean water, if it is stored in a high capacity for larger days, suppose 10 to 15 days, then in distribution network, as I told you, you may require at the end point of the where you are taking the water for directly to drinking, etc. There may you add a small filter and maybe UV. Okay, so that you are safe from any kind of contaminant. You know, when you drink water, it is a pure water, potable water. Similarly, in reverse osmosis also you have sea water or water, brine water, you have intake, then there is a flocculation and coagulation, the sedimentation. These are pre-treatment is essential. Okay, you cannot directly use a RO. So every this water bot sources require pre-treatment, filtration, then you apply RO, right? Then RO, after RO also you may have a filtration here, post treatment you can say, and then you can have a drinking safe drinking water. Here also you can use chlorine tablet because to kill bacteria. If suppose for water is remaining more than 15 days or 20 days or a month or so called, then there may be a bacteria formation. Okay, so to avoid that, sometimes chlorine tablets are added, or maybe you can use directly UV. Okay, there to get a safe water. So this is a typical, plant, seawater desalination plant. If you have a, this is a bay, you have intake water, there is a power plant. This power plant may be hydel power, may by wind or solar or maybe tidal. So this power plant is there. You have pre-screening, then removal of solid and suspended solid, etc. Then again sedimentation, sand filter, then you have earth, microscopic materials are eliminated. So all these are intake is taken and again recycled. So here also you have a recycling. So still some water comes, again it is recycled, okay. And pure the dry waste, or you can say waste without any water will be collected, and this waste is disposed of at proper place. So after this treatment, it is taken pumping. By pumping, it is a cartridge filter. Again, I said to remove the cartridge and carbon filter will there. Then this is pump where pressure is there. In reverse osmosis, this is a pre-pump, is a very low HP pump. When 2 HP are less than that. But here you require a very high pressure pump. So by this high pressure, this RO, maybe single stage or multi. This is a typical example of two stage. So first reject is again processed through second stage, and second stage output and first output is post treatment treated, and then it is captured in a large tank, okay. So this is a typical RO process. So there tanks are there where you also you can use if you want chlorine tablets or chlorine treatments, and then you are pumping the water meters, and then this is a distribution network. Here also there are some storages, regional tank storages, and then there is a pipeline distribution, and you have a water tap. Now here, sometimes, as I said, if there is some possibility of cracks, leakage, seepage in this line, then better this here you can use a filter and UV treatment, so that you can get, or otherwise you can collect water and you can use in household filter and UV treatment to get a safe drinking water. Okay. So now if you see the applicability of renewable energy sources, so there are different types like thermal technologies and membrane, typical membrane use. Okay. So all these are the different techniques of desalination, and renewable energy is required. Renewable technology is used for all processes, ED, RO, etc. Solar PV, solar panel is used for VC, RO, and ED. Wind energy is used for all stages. Even geothermal. Okay, nowadays geothermal energy also used for this all. So now, depending upon what, because all these processes require some power. So electricity power is also a limitation in our country. So to supply sufficient power for this desalination processes, so you have a this renewable technology like solar PV, wind, or geothermal. It along with that you can have a hybrid with the normal electricity available, so that your plant may run 24 hours into 8 days to supply potable water to the community. If you do the analysis, okay, of this desalination methods of using renewable energy resources, then you can say solar, there are different methods. Okay, I will not go into details, but these are already listed. Okay, wind, geothermal, etc. The capacity, what is the plant capacity? Solar steels less than 0.1 millicube per day. Then for solar multiple effect, that 1 to 100. So depending upon what capacity of plant have, okay. Then you can see that wind energy is in a high capacity plant. Okay, solar and this is used for high capacity thermal electrical energy. Yeah. Okay, so what is the cost? So treatment cost is here listed. Is a tentative. Okay, it is not exact, but depending upon the area and the resources, etc., and what infrastructure has been put. So depending upon that, the cost is involved. So these are the cost, and mostly now it is application. If you see that solar steels and all are in application, while other methods are still in R&D or basic research, like wind, mechanical vapor compression. It is still not. It is still in the basic research. It is not still applied in fields. Okay, other methods are already applied in fields, and people are using these techniques to get the potable water from the brine or sea water. Okay. So here in particularly our institute, CSR Siri Pilani, here our group, we have developed we are working from 2005 in RO, water treatment, water quality measurement, etc. So we have developed system here like embedded RO plant monitoring system, and some systems for water and aquaculture, as you can see that picture and informations, and these are already deployed in different part of villages along with the RO plant to get. So let us currently last 2 years back we have installed more than 50 plants in Rajasthan with IoT. Okay, so you get data continuously with the from 500 liter to let's suppose 2000 liter per hour plant capacity. You have a all IoT based controller, so you have data, and then it is having a all in one portal. So all operations are done with the IoT based system. So what it requires RO plant status monitoring, RO plant membrane health prediction. So what it gives, that it will reduce the it maintenance cost, and there is a what we have seen, that in our plant requires the maintenance. If you do not do regular maintenance, then the plant will be shut down, and what will happen, the people will get affected with the drinking water. Okay, so to avoid that, this data, this IoT enabled water treatment plants and water quality plants, similarly here also for fish ponds, these are also IoT enabled system. This is a fish feeding system. This is also a motorboat system, which is water quality measurement and feeding. This is a 2 hectare pond. This is for small ponds, less than 1 hectare. Okay, so this all technology we actually developed in Siri and deployed successfully in the different part of villages, whether it's eastern or western part, Rajasthan, etc. And technology has been transferred to the two industries to develop all these systems. Okay, so with this, I think I'm thankful to you for listening. If you have any questions or anything, I have email ID at the first slide, so you can email me, and whatever your doubts or whatever kind of help required, best possible way I will try to solve your problem, whatever knowledge I have with me. Okay, so this is my email ID, so you can communicate with me through this email ID. Thank you. Thank you again.
I'm here to propose the vote of thanks on behalf of the organizers of the webinar. I thank Dr. Shashikant sir for his thought-provoking and scintillating speech. It was a great pleasure to listen you to, sir. I thank once again for your time and interesting speech. Thank you.
Now I invite Mr. Shailesh Lende, and he is going to speak on IoT in insurance industry. With first, let me introduce him to you. Mr. Shailesh Lende is technical specialist at Travelers Insurance, Hartford City, USA. He has more than 12 years of IT experience. In that, he works on IoT domain. He have worked for leading companies in USA like GE, Tokyo Marine, CSA, Jayco, etc. He has also core experience in all new age technologies like Angular, React, MuleSoft, AWS, etc. He recognized as a subject matter expert for building customer facing applications. He also leading a team in designing the architecture to develop mobile application in next gen technologies. He has excellent soft skill like verbal communication, presentation, etc. He has also organizational and interpersonal skills, strong leadership skill, etc. Now I welcome again Shailesh Lende to deliver his speech.
Uh, Today's topic is IoT in the insurance industry. So basically, how IoT is boosting and changing the entire uh, insurance industry, the way insurance industry works, or the way they do the business. So let's start. So before discussing all the points, I want to give you little bit introduction of mine. So my name is Shailesh Lende. I am a graduate of computer science, and I have total 12 years of experience, IT experience. So I've been working in USA based insurance domain for more than 10 years now. And mostly it's in insurance business. I'm working for personal insurance line of business. Also, uh, I work for leading insurance companies like General Electric or AAA, Tokyo Marine, Allstate, I was working in Dallas, Texas for those companies, and also my specialized skill are in developing and designing the end customer facing applications. Currently, I'm working as a technical specialist in travelers insurance, which has its headquarters in Hartford, Connecticut. So my current project actually is actually building a latest app, with all the advanced technologies, um, which the app will be used by the end users, the mobile app. Also building the new services using um, AWS, MuleSoft, all latest technologies. Okay, so these are the topics or points which we are going to see today. So basically, what is IoT? Wow. Then the high level architecture of the IoT. Then in the IoT system, what the basic, what are the different components, or you can say layers of IoT. Then why we should go IoT, because the business was running earlier as well. Then what exactly, what what's new IoT is giving us? Why all the industries are acquiring IoT? Not only insurance but all other industries as well. So basically, I am coming from insurance domain. I will just give you some brief introduction of insurance, the way insurance industry works, or the way insurance industry do their business, and also we will see some use cases of insurance industry where they are using effectively using IoT. So let's start first of all. What is IoT? So basically, IoT stands for Internet of Things, which refers to the use of intelligently connected devices and systems to gather, process, and analyze, also the controlling the data. And all this it does without any human intervention. So all this does done by automatically. So once you set the IoT system, it does all these things, gathers data, process it, sends to some data center, and then that data can be used by the water industry. We are using IoT. So basically, in very simple word, we can say IoT is like everything is connected. So if we see IoT in industry category, so basically there are so many industries with different domains. So this is the diagram, which it will give you some idea. IoT is categorized in three different categories, and each category has some domain like intelligent environment. So if you see the smart cities, and the transportation during the cities, also the intelligent building, the building, if you make a intelligent way, it comes under intelligent environment category. Intelligent living is actually automotive, smart cars, or the consumer electronics. There are some consumer electronics appliances which comes under intelligent living, and the rest of the domains like construction, real estate, manufacturing, all these are comes under intelligent enterprise. So let's take an example so that you will get some more idea, like how IoT is changing our entire the way we use any of the system, or any of the utility. So like suppose it is a smart city, you will have a smart street lights. So the street light will be depending on the ambient conditions, like if it is a cloudy, the lights will on much early before of your regular daytime. If it is sunny day, they will start after the sunset, when it is darker. And so basically they are saving the energy, and this is not something no human will adjust this time. You will just set up give the instruction to the IoT, and it will follow, and it will control the the lights. Similar way, like if you are traveling through public transport, suppose, so in public transport, and if the transport is IoT enabled, you can actually see, okay, where is your bus, how much it is loaded, whether it is no, it's on track, it is little bit late, or you can book the ticket. If you miss that bus, when is the next bus, where exactly it is, you can all this information is available, so like real time updates for passengers. um Another example, good example, which is very effectively being used in US, is like the smart traffic lights. Like, suppose any vehicle which is violating any rule, suppose it's over speeding, or it's breaks the red traffic light, and these there are some cameras mounted on these traffic lights. They will take the picture, they will send a copy to the person who has break the law, also to the DMV department. The DMV means like RTO of that particular city, and it keeps that track record as well. Like, if you break that rule multiple times, it will report to the DMV, and they can block your license. Also, like camera, CCTV, not the manual CCTV, monitoring. The camera itself will watch for the crime, and if any crime happens, they will report to the nearest police station. Another example which we will see in detail, like in car insurance, you can enable mount uh, a device on your car, or in your phone, and depending on your driving habit, you will either get a discount, or you will have to pay more for your insurance. You will see that in detail. So this is just high level example of smart city. uh, Another example, good example, is a smart home. Like, everybody knows Alexa. So in like using Alexa, you can do your home smart, but there are some other IoT devices as well. Using that, you can make any smart home. Like, if you have AC, air conditioning, you can control your temperature depending on the outside temperature, or during night you can set different temperature. When you're, suppose you are coming to your home, you want your home to be cold enough, you can set all this instruction, and before arriving home, the AC will be turned on, and the temperature will be already set. Or the lights, they can depending on your mood, depending on your habits, or you can program them, and they can either turn on, off, or their brightness, you can dim them, or increase that. Music, also same thing, you can use it. Security for your home, you can whether you are at home or outside your home, you can monitor all the security cameras, the security gate. If something happens, the system itself will report to the nearest police station. That kind of thing comes under the smart home. So this is very good example of effective use of IoT. So let's see how the IoT architecture is. So here you can see on the left hand side, there are different blocks like temperature, humidity, pressure, motion. These are the like kind of sensors. So basically any IoT system will have some sensors, because these IoT are connected to the things. Depending on what kind of appliance it is, what kind of functionality that appliance is doing, you need these, or maybe more than these, some kind of sensors, to capture the data. Then the sensors will send that data to the IoT framework. So it's framework or gateway, whatever where the data will be processed, and that gateway actually connects to the server. That server could be the cloud server. So it directly transmit that data, or sends that data to cloud server. So here is the communication is wireless, so that's why your IoT device you can embed that device to anything, and because it is wireless, it can send that data from any place anytime. And from that cloud server, you can make, then if once you have that data, you can make use of that data, like you can actually send that data to the end user. You can actually see that data on your mobile app. You can analyze the data, control the your IoT device, or you can process the data further depending on your requirement. So this is how the IoT architecture works. So any simple IoT, if you see, these are the minimum components, or you can see in any of the IoT system. So starting from the left side, you can see the sensors or actuator to capture the data. So as we mentioned, as have seen on the earlier slide, we need the sensors to capture data. This data has been sent to the data acquisition system DAS, and in this system, you can do the aggregation or the measurement. You can also control your what are your parameters while capturing data. You can control that. And then there will be pre-processing, because this data will be in the form of the IoT, but to send to data to the data center or cloud, you may need to do the pre-processing. So you will need a preprocessor, and it can be used for analytics. And then the preprocessor can send the data or upload the data to the cloud, and there it can be used for um, analytics management, or it can be archived for your future use. So this is the uh, simple uh, components for IoT. Now let's see why IoT, like why we should go for IoT, or why every industry is acquiring IoT. So if you think logically, you can see. So if you don't have IoT, whatever task we are getting done by IoT, or we are telling the IoT device to do, if we don't have IoT, has to be a manual intervention. Like you need a manual resource for to do that task. So whenever any manual thing, resource comes into picture, you have to think of giving the the expenses. You have to pay the salary. There will be if one resource goes out, new resource come in, there will be a kind of knowledge transfer, transition time, then learning, all that. It entirely, actually, if you it results in a more money or higher cost. So if we use the IoT, basically that cost we are saving. So definitely there will be a cost reduction. Again, when there are humans are more error prone, but if you have system or automated system, a machine is a less error prone. So basically, so if you have less error, so your efficiency will be good, and due to less error, your productivity will be automatically increased. So you definitely will get better efficiency and productivity. Also, as we have seen, that once the data in IoT which is uploaded in after pre-processing, analyzing, it is available in the cloud, and from cloud it is available to anywhere, anytime. So basically, you can control your IoT device from anywhere and anytime. So you don't need to be you don't need to be sit at any one place. You can do it from you will get the mobility. So that is something, big advantage. Also agility, like suppose depending on your need, depending on your some certain condition or some time period, if you want to make some changes, you can do it very quickly in this IoT. So the agility is also there. Obviously customer experience, because you are, whatever your industry is serving is doing for customers. So the customers will have access to all the data, So basically you will get better customer experience, and your customer will be happy. Definitely you will increase the business, and that's the business opportunity. So more and more the IoT is getting evolved. There are different opportunity in your business. You can use this IoT enabled systems, and definitely your business can grow up. So that's why every industry is going for IoT, or they're trying to whatever manual thing if possible, make it IoT enabled. So this is all what IoT is. Now let's understand, just small brief introduction about insurance. So what is the insurance? So everybody know, like, insurance we take actually, so that we suppose we are losing something, we should be protected. So basically, simple word, insurance is transferring the risk. So everybody is living under the risk. We are living under the risk because of risk of right now the COVID situation is going on. So risk of getting ill, risk of some jobs some people are doing, riskful job where the risk of life is there. For your business, the risk of market is there. If market goes down, you can go bankrupt or something. If for your car, it's a risk of it's running on road, that's a risk of accident. Even if you are not at fault, someone else can come and hit you. So there is a risk, and you can lose the money. So basically there is always a risk. So insurance is basically transferring the risk. So if I am a person, if I get insured, I am transferring my risk to the insurance company. But why they will accept my risk? So basically they will ask me to pay the premium. So if I have to pay some premium, so suppose I am paying them 100 rupees per year, but they are covering my risk. Suppose something happens, they are covering my risk for 10,000 rupees. So that's how premium is, the proportionate of premium versus the coverage is getting calculated. So basically, if any damage, what insurance does, so suppose if something bad happen or any damage happens, the insurance will restore the person or the thing, or the vehicle or whatever it is, to the stage before the loss. So if any accident happens, and if my car is insured, insurance will try to cover that expense, whatever repair, or if the car is completely damaged, whatever the amount I need to buy a new car, they will cover up to some maximum extent, 80%, 90% kind of thing. So that's how the basically insurance is. But now, as I told you, insurance, we have to pay the premium. So how they calculate the premium, like, because insurance, any insurance company, they have to sell their insurance policy to maximum people. So what they do, like, if they sold the policy, or if they covered 100 people, and out of 100 people, only 5 people get damaged, they are they only then they can cover your loss. So that's how their business works. So basically they collect the premium from 100 people, but in worst case scenario, not all 100, it's impossible all 100 will get impacted by damage or loss. Out of 100, maybe 5 or 10 people will get impacted, and they can uh, aside from apart from their profit, they can cover their 10 people for their loss. So how they actually calculate the people, so there are some concept of coverages, like, there are, I will not go in detail, it will be more technical, or for insurance domain, but there will be coverages and rates. So in US actually, or in everywhere actually, the coverages and rates are decided by underwriters. So underwriter is the one kind of designation in insurance, which are the um, cream layer, which we can say, of insurance industry. They decide the rates depending on calculating their profit, and also the possibility of damage, and the people, depending on where they are living, what are their where they are kind of parking their car, where is their home, or if it is health insurance, what are their age and all that, they calculate the coverage. And then Also, like, uh, to to apply the rates for this coverage, they have some certain formulas, they have some mathematical formula. And for that, the traditional way of collecting the data from the insured, suppose they want to sell me an insurance policy, they will ask me some questions like, where do you live, what is your age, kind of thing. If it is a health insurance or even car insurance, they will ask me, where do I park my car, or what kind of car I have, kind of question. Also, like, uh, they will also run kind of third party reports, like, there are some institution which keeps the track of every person. So, like, for me, if for my record, there will be one company which will maintain my record, so they will run the reports against that company to check whether I have done any illegal things or any violation, kind of thing. And if they find something, depending on their policy, either they will charge me high premium, or they can actually, they can go for, okay, we don't want to sell the policy to you because you are kind of fraud thing or something. So that's how the traditional way, or the usual way for calculating the rates. But now, like, if you have IoT, then we will see actually how IoT is changing this. So we'll go in detail in the coming slide, but I will just give you some idea. Like, it will be a user base, like every individual, they will consider different individual, and they track their behavior. So let's see. So before discussing that, let's see what are the types of insurance. So there are basically high level two types, two lines of business they call personal lines of business, like individual. So suppose you want to insure a car which is personal, individual owned car, or individual home, it will be a personal line of business. And commercial, like the car is owned by some company, or the property owned by some company, it will be commercial line of business. Or if there is one insurance like workers compensation, like for insurance of the employees. So employees working for company, but the company is paying, buying the insurance for their employees, something happened to them during their working, or during their work hours, the company is going to cover their expenses. So that kind of thing comes under commercial lines of business. uh, so as I said, like, auto means car in USA. Auto insurance basically are car or motorbike insurance. Property is actually home, your rented home or your own home, or anything inside your home, your personal item, your valuable item, comes under property. Health insurance, as we have in India, same as health insurance related to health. If you feel sick, then it is covered. And the life insurance, so same as India, they have. Now let's see the telematic system. So here, whatever you see the picture, actually this is a IoT device. One of the insurance company, Progressive, use this device, and it is actually a telematic system. So either the insurance company have these devices, or they have the mobile app, IoT enabled mobile app, to collect the different data, and they are using this. So let's see how it works. So basically, as I told, insurance premium calculation, the old method or the existing method is accessing historic data. Like, if they want to see my record, they can actually run the reports, or check kind of history, they can check and see whether I did any violation or not. And addition to that, to have a new kind of um, insurance opportunity, or in increasing their business, what they do, actually they record our day to day behavior, and analyze that behavior. Like, if I am buying a car insurance, and they will record my driving habits, analyze it, and depending on how my driving habits are, they will they will either charge me high premium, or give me discount. So basically, it's called as user based vehicle insurance. So what it does, uses the individualized data gathered by the IoT sensor. So IoT sensor, just whatever I showed you, is it can be a device or a smartphone app, And what it does, it actually checks the driving skills, so to calculate the the risk factor of particular driver. So if a driver is very rash driver, if he's doing kind of hard brake, or all of a sudden acceleration, or it's over speeding, definitely the driver is going to meet the accident. So because the car is insured by the insurance company is it's looking for the car should not get damaged. They will definitely, if that particular driver which is not having good habits of driving, they will charge more premium, because something happens they have to cover that one. So that's how it works. So you can see UBI systems actually, it monitors the driver's adherence for safe driving techniques. And if you are following the safe driving techniques, like for 1 month, if you drive as per the good driving habits, you will definitely get discount in your next renewal. So that's how it works. Also, this data is also available for the driver. So suppose and you can, and that data is available for every trip. Like if you drive from here to college, during that trip you can see how many hard brakes you had, how many over speeding you did. So over speeding, because in USA every road has a speed limit, and that record is there for to everyone. Like Google Maps map has that record. Also these IoT enabled devices, they also access this GPS. So they have that record, so they will know, depending on your sensors, whether you are horse speeding or not, you are doing hard brake, they can find out. So, and you can also monitor that data on your trip basis, so you can actually improve. If you want to save the money, you can improve it. And that's how company will also give you some discount. So that's how they are effectively using this devices. So this is a kind of flow diagram for these telematics. So this is you can see in the first step, the data is generated. So the sensors, the device which is connected to the car, or the app, IoT enabled app, mobile app, which is in the mobile driver's phone, that will generate the data is generated. And then the generated data is recorded in the application. So if it is a mobile app, it is recorded to the application of the smartphone. Then this record, customer driving data automatically sends to the data center, and this data wirelessly actually it is transmitted. In the next step, you can see the data has been collected by the insurer. So basically this data is available for the insurer first. So insurer is the insurance company who is actually issuing the policy, and insured is the person who is getting covered. So insurer will have the access to this data for their data analysis. So every company have the data analytics. So this analytics also done automatically, it's not manual analytics. So they have their all formulas, and this data get analyzed. So you can see in the third step, after the data is getting analyzed, insurer actually reviews and aggregated data, and then it creates the customized policies. So it depends on the data, it creates the customized policies for that particular driver. So it prepares that policy, and during that insurance term, if you have the same habits, then this policies get reported to the underwriter, who applies the rate to the person. And depending on the rate, you either you have to pay more, or you will get discount. That's how it works. And also, in fourth step, as I said, this data is also available for the driver who is driving, to motivate him, or to educate him whether where he exactly he is doing wrong. So if he wants, he can actually improve his driving habits, and he can save money. That's how uh, the telematics is used uh, in insurance, in auto insurance. So another use case for IoT in insurance is claim processing. So before that, let me give you some idea like how this like after once we buy the insurance, right? So suppose the insured buys the policy, then let's say some damage happens, some loss happens. So suppose insured have purchase a policy for his home, and then some natural calamity came, maybe because in US it's very certain states have, like in south US there will be tornadoes, or and in the east there will be hurricanes, snowstorms. Then in California there will be forest fire. So all these kind of natural disasters happens very frequently over there, and people home get damage. So and in and as I said, like in US, every maintenance cost is very high. Like for car, it's if something happens to your car and if you don't have insurance, you have to pay thousands of dollars just for small work. Like suppose you are just change the engine oil, they charge 200 $300. It's very high. Like if you fell sick and if you don't have insurance, the medical treatment apart from the doctor's bill, the hospitalization, if you get hospitalized, the charges are very high. Same thing for with the home as well. Like if something something gets damaged, the repair cost or maintenance cost is very high. So you have to have the insurance. That's very must thing in US. So what we are talking, like suppose some natural disaster happens, then the insured has to report. The very first thing he has to do is to call his insurance company. That is a protocol they have to follow, because something happens. If they want that particular damage to be covered, they have to call the insurance company and report the incidents to them. So it's kind of first notice of loss, they call it. So they have to do that. That is a protocol they have to follow. Then insurance company, the traditional way was doing, like insurance company was assigning that claim to some office, nearest office to that whatever, wherever the loss happened or damage happened. Then their actual auditor has to come to the place, audit that place. Until that, you cannot move your things. So that was the by law, you cannot move anything. If something happens, suppose you meet an accident, you should not touch your car unless the police comes and also the insurance guy comes, because then only you know your damage will be covered. So that's how. So that was the earlier process. Then insured, then the insured has to file the claim, and that claim was getting settled. But now using the IoT enabled drone, what happens if the effective use of IoT, if something happens, um, the insured just have to message or tap on one single button, and the insurance company will send its drone, which is IoT enabled, which will actually go to the address, take all the pictures, and also upload that pictures to the insured portal, as well as sending to insurance company. And that way it is actually fasting up the process of entire claim, and the claim will get settled very quickly. The insured will can actually repair his home very quickly. So that's how they are using it. Travelers is actually using um, like they have this kind of IoT enabled drone, and they are very effectively using for claim settlement. So this is very good example in insurance of how IoT is being used. Another example or use case, you can say, is a smart healthcare. Like if you are having a healthcare policy, so you using a smartwatch or on an app. Insurance company provides some app, or in a smartwatch they can provide a app over there, or they can provide a smartwatch, and they can monitor your health. And depending on that, they can either suggest your the different ways to be to be healthy, or they can also, depending on your general habits, they can change your premium. So that's how this is also they are using the IoT based for the healthcare policies. Uh, so like this is, like you can see, like IoT is everywhere now. Not only insurance, each and every sector is actually, to improve their business, to what are the benefits we have seen, and for better user experience, we are seeing each and every industry is going for IoT. And this could be in some near future. We can, this is a hypothetical picture, but you some of the things already happened, but some of them maybe in future you can see, like if everything is IoT enabled, if you are doing a farming, or you have or apple tree, if the apple is ripe, you will get a message, okay, it's time to pluck it. Or if you lost something, and that particular thing, suppose the key is IoT enabled, you will never lose anything. You basically, you will keep track of where exactly you have forgot it. Or your parents can monitor their kids. If they are playing, they can parents can actually see, okay, where exactly their kids are, what they are doing, if it is IoT enabled. Or suppose in a supermarket, or in a store, if any of the container, it's suppose the milk is out of milk, you don't need to, your labor who is working over there don't need to check your stock, right? It will automatically, it will keep track of the stock. And if whenever it is losing the stock, it will send a message to the owner, okay, we have to refill. Or like the dustbin, if it is whether it's a if it is full, you have to change the dustbin bag, kind of thing. Manual already have seen. Then the car also, if you are driving, and that I think in Google Map already supports it. But in car also, like suppose any accident happens, it will get reported, kind of things. So yeah, maybe in near future you can see this is all happening, because IoT is the kind of cutting edge technology right now. So it's it's being used almost every industry. So as you have seen, like IoT is basically an it's a concept of electronics. So even for travelers, I'm working for travelers, but in travelers also, what are the telematic system is developed and built by electronics company called IntelliDrive. So it is just outsourcing. So basically, if you are looking for some opportunity, there are so many big giants or big companies we are actually working in IoT. These are some some examples, some top 10 top 15 US, like these are US based companies, but they have their offshore center in India as well, who are big names in the IoT. So like if you are looking for this this area or this sector, you can definitely leverage your skills over here, and there is very big scope I can see. So I would want to wish you all the best for this, if you are looking to enter in this area or these skills. Okay. I hope, yeah, that's all I had. Thank you so much, and all the best.
Thank you, sir. It was great pleased to listen to you, sir. Thank you very much. We are moving towards the end of the webinar, and I would like to call upon Miss Priya Rupramar to propose vote of thanks.
Good afternoon, all of you. Myself, Rupnar Priya. On behalf of the Department of Electronic Science, Tuljaram Chaturchand College of Arts, Science and Commerce, Baramati Autonomous, I take this opportunity to propose my vote of thanks to those who directly and indirectly contributed to this 2 days international webinar on innovative research trends in green electronics and allied technology organized by the college. So, a big thank you to Dr. A.D. Shaigram sir for his effective talk towards design techniques and technologies for green electronics. I must mention our deep sense of appreciation for Dr. Shashikant Sadistap sir for his explanation on water quality aspects and treatment methods to get usable water. Further, we are grateful to Mr. Abhijit Borgule sir for delivering a talk on artificial intelligence for smart electronic devices. I would like to express our sincere thanks to Mr. Shailesh Lende sir for giving an excellent coverage to IoT in insurance industry. We all are inspired a lot by all of you speakers' words and enlightened with your knowledge and presence. Finally, I want to thank to the chairman and honorable principal Dr. C.V. Murumkar sir for his enthusiastic support. Also, I thank to convener and vice principal Dr. J.D. Deshpande sir, the RUSA coordinator and vice principal Dr. A.B. Telve sir, co-convener Professor S.H. Gowde sir, organizing secretary Professor Y.T. Elpole sir, coordinator Dr. A.M. Pawar for their support and suggestions. A special thanks to the organizing committee members Mr. A.S. Kothare sir, Mrs. S.A. Gowde ma'am, Ms. P.M. Jarande ma'am and technical support committee members Mr. Nakate sir, Rahul Chaudhary sir and Vishal Shah sir for their support and cooperation. Last but not least, our heartfelt thanks to our participants for their active participation. With these warm words and a kind message, we move to the end of this 2 days international webinar. Thank you.